Good morning, dear student. Welcome once again. Today we will solve the numerical problem of chapter number 18, which is about dawn of modern physics. So, according to the SMART syllabus, the numerical which are included in our SMART course are numerical number 1, 2, 3, 4, 5, 6, 7, and also numerical number 10 and 11. So we will solve these 9 numericals from chapter number 18, which is about dawn of modern physics. So let's start properly. You have to note this pattern. What is stated in numerical number 1? The length of a spaceship is measured to be exactly 1/3 of its proper length. What is the speed of the spaceship relative to the observer? So length is given, we have to calculate the speed of the spaceship. So to solve numerical, very simply, first of all we have to collect the data from the statement. So question number 1 or numerical number 1, we have to collect the data. Given data is what is given? Let me read this question. The length of spaceship is made to be exactly 1/3 of its proper length. So rest length is represented by rest length. This is represented by L0. Rest length is also known as proper length, and this is the 1/3 of its proper length. What is the speed of spaceship relative to the observer? So length in motion will be, this is rest length. Length in motion. Say suppose length in motion is represented by L. This will be the contracted length. And this is equal to 1/3 of the rest length, L0 divided by 3. What we have to calculate? We have to calculate the speed of spaceship. Required is what is required? Speed of spaceship. Speed of spaceship is represented by speed v, simply v is to be calculated. Here also we know that speed of light is represented by symbol p. This is represented by symbol c, and this is equal to 3 multiplied 10 power 8 meter per second. So this is the given data, and what is required, we have to calculate the speed of spaceship. So dear student, very simply, this is one of the basic consequences of special theory of relativity. So by applying the formula, we know that let's apply the solution here. We know that L is equal to L0 under root 1 minus p square divided by c square. Say suppose this is equation number 1. We have to put all the values from the given data in equation 1 to get the speed. So instead of L, we can write L0 divided by 3. Putting values here. What we get, instead of L, we have to write L0 divided by 3 here. So we get L0 divided by 3 is equal to L0 into under the root 1 minus v square divided by c square. So by simplifying this, we get 1 divided by 3 This L naught will be cancelled with L naught. So we get 1 divided by 3 equal to under the root 1 minus v square divided by c square. Taking square both sides, we will get 1 divided by 9 and 1 minus v square divided by c square. So by taking the square, we get this. If we shift this term v square by c square to the left hand side, we will get v square divided by c square equal to 1. This will shift into this right side, 1 divided by 9. Taking LCM 9, we will get 9 minus 1 divided by 9 equal to v square divided by c square. Now we get, let me solve here, v square divided by c square equal to 9 minus 1 divided by 9. So it will become 8 divided by 9. So v square divided by c square equal to 8 divided by 9. Now we will shift this c square to this side. So v square equal to 8 divided by 9 into c square. Now we have to calculate v. We have to take square root here. Taking root both sides, this will cancel with this. So v equal to under the root 8 divided by 9 and c square will become c here. Now what will be the root value of 8 divided by 9? It is approximately equal to 0.9428. V equal to 0.9428 c. C represents speed of light. So this is the required speed of spaceship when it traveling with the speed comparable to the speed of light. So it is very simple. Let me summarize it once again. Rest length is L naught, and it is given in the statement of the question that the length in motion will be 1/3 of the rest length. So L will be equal to L naught divided by 3. This is universal constant speed of light, c equal to 3 multiplied 10 power 8 meter per second. What is required? We have to calculate the speed v of spaceship. So for calculating this is one of the consequences of special theory of relativity, that L is equal to L naught under the root 1 minus v square divided by c square. So we get, by performing this calculation, we get that v equal to 0.9428 c. So dear student, from this special theory consequence, we can conclude that when an object gains a speed approachable or relative to the speed of light, then its length will be contracted. To an observer sitting in another reference frame, it will seem that its length is contracted. So this is length contraction. In second numerical, it is stated that time period of a pendulum is made to be 3 seconds in inertial frame of reference. So let me solve second numerical. Lesson number 2. Given data. What is given? The time period of a pendulum is made to be 3 seconds in inertial frame of reference. Inertial frame of reference is a frame of reference which is moving with either it is at rest or moving with uniform speed. This is also called non-accelerated frame of reference. In simple word, we can define inertial frame of reference is that the frame of reference which has zero acceleration is called inertial frame of reference. Now, the time period is given. What is the period when made by an observer moving with a speed of 0.95 c with respect to the pendulum. So there are two frames given. One is inertial frame in which the time period of simple pendulum is 3 seconds, and we have to calculate the time period of this pendulum from the other frame of reference in which an observer is sitting and observe the motion of this pendulum. So how can we calculate? This is another consequences of special theory of relativity, which is time dilation. So what is given? Proper time. Given data is proper time period at rest. So proper time period, which is equal to how much? 3 seconds. Relative velocity is also given. Relative V is equal to 0.95 into c. Remember, this c represents speed of light. Speed of light is given c equal to 3 multiplied 10 power 8 meter per second. Speed of light is represented by c, and it is equal to 3 multiplied 10 power 8 meter per second. Now we have to calculate the time period of this pendulum from another reference frame, which is called dilated time. We have to calculate the apparent time period or dilated time period. So what is required? Apparent time period. T. Dear student, this proper time period or rest time period will be represented by T naught. This is T naught, and this is equal to 3 seconds. So very simply we can solve this question by applying the time dilation formula. So solution. By time dilation formula, we know that T is equal to T naught divided by under the root 1 minus b square divided by c square. So T naught is given, V is given, C is given. By putting all the values here in this equation, we can simply calculate the dilated time period. How can we calculate? So putting the values here, we get T equal to T naught divided by under the root 1 minus, what is the value of V square? What is the value of V? The value of V is 0.95. So 0.95 C, but it is in square divided by C square. Further simplification, T equal to T naught divided by under the root 1 minus 0.95 square C square divided by C square. This C square will cancel with C square, so we get T equal to T naught divided by performing this calculation, we get 3 divided by under the root 1 minus, now 0.9 square is equal to 0.9 multiplied by 0.9, we get 0.09025. This is very simple calculation. So T equal to 3 divided by under the root. By simplifying this, we get 0.0975. 0.0975 0.0975 t is equal to 3 divided by 0.0975 under the root is equal to 0.312. So 3 divided by 0.312, we will get 3 divided by 0.312. So by performing this simple calculation, we get 9.6 second. T is equal to 9.6 second. This is time dilation, dilated time. So dear student, you can see that the proper time is 3 seconds in a reference frame. If we are here in this room, this is for us, the reference frame. So in this room, we will observe that the time period of the pendulum is 3 seconds. But if we are moving with the velocity 0.95 comparable to the speed of light, and the other observer from other reference frame will observe that the time period of simple pendulum is 9.6 seconds. There is a huge difference between 3 seconds and 9.6 seconds. That is the phenomenon of time dilation, which is the second consequence of special theory of relativity. So it might be clear. Let me summarize briefly it once again. Proper time period is given, which is 3 seconds. Relative velocity is 0.95 into speed of light. So speed of light is 3 multiplied 10 power 8 meter per second, which is a universal constant, which is equal for all the object. Either the object is at rest or it is moving. So the speed of light will be same. Apparent time period or dilated time period is t. By this formula, t equal to t naught divided by under the root 1 minus b square divided by c square. We can calculate this dilated time period by simply performing this calculation. Now in question number 3, what is given in question number 3? In question number 3, it is stated that an electron which has a mass 9.11 multiplied 10 power minus 31 kg move with a speed of 0.75 c. Find its relativistic momentum and compare this value with the momentum calculated from classical expression. So we have an electron, the rest mass of electron, you already know that it is equal to 9.11 multiplied 10 power minus 31 kg. But it is given in the statement of question that this electron is moving with very high speed, 0.75 into c. What will be its relativistic momentum and the momentum calculated from classical physics? We will compare these two momentum. So let's start. Question number 3. Given data, what is given? An electron which is a mass 9.11 multiplied 10 power minus 31 kg. So directly write the rest mass of electron, which is m naught. This will be the rest mass of electron. M naught equal to 9.11 10 power minus 31 kg. This is the rest mass of electron. Move with the speed of 0.75 c. What is the speed? Speed of this electron is 0.75 into speed of light. Find its relativistic momentum. Now what is required? This is given data. Required is we have to calculate relativistic momentum. Relativistic momentum is represented by symbol P. P is for momentum, and this R. PR is the relativistic momentum for this electron. With this, and we have to compare this value with the momentum calculated by classical physics, classical expression. So how to calculate this relativistic momentum? To calculate this relativistic momentum, first of all we will calculate the dilated mass. Solution. We know by a formula that P equal to P relativistic equal to mB. This will be the dilated mass. This is m naught, which is rest mass. This m will be greater than the rest mass. Because wind speed increase, the mass of object also increase according to modern physics. When speed reach to the speed of light, what will be the mass? Mass will reach to infinity. So P relativistic equal to m into v. This is say supposition number 1. Also we know that m is to be calculated like this. M equal to m naught divided by under the root 1 minus v square divided by c square. So all these values are given. M equal to m naught, which is the proper mass. This is dilated mass divided by R. This is also known as relativistic mass. 1 minus. What is the value of V? V value is 0.75. So 0.75 C whole square. Because this is V square divided by C square. So by simplifying this, m equal to m naught divided by under the root 1 minus 0.75 square into c square. This square is on both 0.75 and c divided by c square. This is c square. So cancel this c square with c square. We get m is equal to m naught divided by under the root 1 minus 0.75 square is approximately equal to 0.56. By taking square, we get 0.56. So 1 minus 0.56. Similarly, m is equal to m naught divided by 1 minus 0.56 under the root is approximately equal to 0.66. 1 minus 0.56 under the root will be equal to 0.66. Now it becomes very simple. We have to put the value of relativistic mass, which is this one. Sorry, the value of proper mass m naught, which is 9.11 multiplied 10 power minus 31 kg. So putting this value in this equation, we get here m is equal to, what is the value of m naught? 9.11 multiplied 10 power minus 31 kg divided by 0.66. So by performing this calculation, we get 13.8 multiplied 10 power minus 31. So m is equal to 10 power minus the same 31. kg. Now putting the value of this in equation 1, we get, put this value of m in equation 1, we get, put in equation 1, we get relativistic momentum or PR is equal to 13.8 multiplied 10 power minus 31 multiplied by V. What is V? V is 0.75 into C. Now it becomes very simple. So PR, or relativistic momentum of the electron, will become 13.8 10 power minus 31 0.75. The value of C is 3 multiplied 10 power 8. By performing this calculation, we have to multiply 13.8 with 0.71 and then with 3. We get 31.05 multiplied 10 power minus 23. So very simple. 31.05 multiplied 10 power minus 23. Kg into meter per second. This is the unit for momentum. What is this? We calculate the relativistic momentum of an electron when it is moving with the speed comparable to the speed of light, which is 0.75 c. Now, how can we calculate the classical momentum? The classical momentum is calculated from the rest mass. So, let me rub this thing. The remaining part of the lesson we will solve here. The classical momentum is given by P m naught V. Remember, m naught is the rest mass or proper mass of electron, which is 9.11 multiplied 10 power minus 31 kg. So putting values here, we get 9.11 multiplied 10 power minus 31 multiplied by what is the value of V? 0.75 into C. So P is equal to 9.11 multiplied 10 power minus 31 0.75 multiplied by what is the value of C? 3 multiplied 10 power 8. So this will be the classical momentum. By performing this calculation, we can get just simply multiplied 9.11 with 0.75 and then with 3. We get 2.04 multiplied 10 power 22. 2.04 multiplied 10 power minus 22. So this is 2.04 10 power minus 22 in kg into meter per second. This is the unit of momentum or Newton into second. So this is classical momentum, this is relativistic momentum. How can we perform further calculation? Simply by dividing these two, we will get relationship between the classical and relativistic momentum. Here in question it is stated that compare the value of relativistic momentum calculated from classical momentum. So how much percent it will be? So percentage change. How much change occurred? Let me compare these two values. This is relativistic momentum, this is classical momentum. So how to compare these two values? Let me rewrite relativistic momentum is equal to 31.05 multiplied 10 power minus 23, or we can also further simplify this value is 3.14 multiplied by 3.1045 multiplied by, this can be written as 3.105 multiplied 10 power minus 22 kg into meter per second. This is relativistic momentum. Let me rub this. Now it is stated in the third part of the question that find the relativistic momentum of electron moving with the speed 0.755 c and compare this speed with the classical momentum. So this is the classical momentum calculated from classical physics, and this is the relativistic momentum which is calculated from the special theory of relativity, because in this the time is dilated. So how can we compare? The percent change between these two momentum will be equal to relativistic momentum is greater than this classical momentum. PR minus P divided by P multiplied by 100 divided by 100. So this will be, the answer will be in percentage. So putting the values, we get PR minus P. P is 2.04 multiplied 10 power minus 22. PR is 3.105 multiplied 10 power minus 32. So putting these value, we get percent change is equal to 3.105 minus 2.05 divided by 2.04. So we get, let me calculate this value, 1.065 divided by 2.04. This will become 1.065 multiplied 10 power minus 22. 1.04 10 power minus 22 multiplied by 100. This divided by 100 will become percent. So multiplied by 100%. So very simply we get 1.065 divided by 2.04. This will, there are certain cancellation. So percent change in this momentum is equal to 1.065 divided by 1.04 multiplied by 100%. So the final answer will be of the order 52%. Simply 1.065 divided by 1.04 multiplied by 100%. So you will get 52% approximately. This is the percent change in the momentum of the object. Let me summarize this briefly once again. Dear student, very simply, we are given the rest mass of electron and the speed of electron, which is 0.75. This is a very huge speed. So when an electron moves with this speed, we have to calculate the relativistic momentum. For relativistic momentum, we have to calculate the dilated mass first, which is m. Then by putting in the formula PR equal to mv, we get that relativistic momentum of this electron will be equal to 3.105 multiplied 10 power minus 22 kg into meter per second. Similarly, we can calculate the momentum from classical physics by simply applying this formula P equal to mv. This becomes 2.04. This will be the percent change, which is approximately 52%. Half it might be clear to all of you. So inshallah, in next lecture we will solve the remaining numericals. We'll start from numerical number 4, 5, 6, 7. So it is enough for today. Thank you for listening. Thanks a lot.